Hello 8th graders, today you're going to be doing lesson 15 in your workbook, which is comparing data sets. You're going to be comparing statistics like mean, median, standard deviation, and interquartile range. So the first thing you're doing is on page 110, and you're going to be looking at bowling partners. Your job is to look at the data and then choose two of the people to join your bowling team. Whoever you choose is fine, but you must be able to explain your reasoning. So again, use the data, help make your decision that way, and then be able to explain your reasoning. So go ahead and do that, and then start the video again when you're ready. Okay, now that you've chosen your bowling team, hopefully you are able to explain your reasoning here. I'll explain my reasoning for my two that I chose. Again, it doesn't really matter who you choose, it's that you can explain why. So the first person that stood out to me was person B. They have a pretty high average score for their game, and they have a pretty low standard deviation compared to the others. So this seems like this person is consistently getting pretty high scores at bowling. 131 is a much better game than I can do. So I would definitely choose person B, and then I would also choose person C. There's a lot of variability in their data. They have a high standard deviation, but they also have a pretty high mean, and I'm taking what I see here to be improvement on their game with higher scores. I don't know if that's true or not, but just looking at the data, that's who I would pick. All right, moving ahead to the marathon times. In this one, they're giving you two sets of data, and they're showing you their finish times in minutes. So you need to think to yourself, what makes for a slower or faster runner when you're just looking at their times. That'll help you when you're doing this. You're going to answer questions 1 and 2 on this page. Take a few minutes and do that. Try to find a partner to talk about this with when you are done, if possible, and then start the video again when you're ready. Go ahead. Okay, you've answered the questions with the marathon times. Which age group tends to take longer to run the marathon? That should be ages 40 to 49. Higher finish times on this end mean that they are running slower, right? They're taking longer to run the marathon. So overall, the set of data for ages 40 through 49 looks to be higher than the set for ages 30 to 39. Which age group has more variable finish times? That's also ages 40 through 49 because there's a lot more spread in their data. All right. Moving on to the next one, you're going to be given lots of sets of data, and for each set you need to do a couple things. Determine the best measure of center and measure of variability to use. So measure of center would be your mean or median, and measure of variability would be either the MAD or standard deviation. And I'm going to take that out and just say that we're just going to do standard deviation or interquartile range. So those are going to be your options there. Determine which set has the greatest measure of center, and determine which set has the greatest measure of variability. And again, as always, be ready to explain your reasoning. So there's a bunch of sets of data on this part, and there is a A and a B for each set of data. So for this one, you do need to be working with a partner. Partner A will do all of the A problems, so like 1A, 2A, 3A, 4A. And partner B will be looking at all of the B problems, like 1B, 2B, 3B, so on and so forth. So again, you're figuring out the best measure of center, best measure of variability, and then once you've done that, then together as partners you can figure out which set has the greatest measure of center, which set has the greatest measure of variability. Okay? So find a partner that you can do this with and work through this part together. There's 7 pieces, so this might take you a little while, and that is okay. If you're not sure, if you get really stuck at things, look at your lesson summary. At the end of this lesson, it has some good examples about when the mean or median is better, or when the standard deviation or interquartile range is better. So use that to help you. All right, go ahead and then start the video again when you're ready. Okay, since you've looked at those 7 different sets of data, there's just a couple that I want to talk about. We're not going to go through all of them right now. If you have questions on some of them, we can talk about them tomorrow. But first, starting out with data set 2 with A and B. For this one, it would make most sense to use the mean and standard deviation because both of them are symmetric, and so their mean and standard deviation would be the best to use there. Set number 3, for this one, the median and the interquartile range is going to be better, and that's because this data is definitely not symmetric. It's kind of bimodal, but there's more data on one side than the other, and so some of those large or small values are really going to affect your mean and standard deviation. So your median and interquartile range are going to be better there. Data set 5, again, just like number 3, your median and interquartile range are going to be better measures of center and variability. And again, it's because your data doesn't look to be very symmetric. It appears to have a lot of variability in some parts of your data. Like on 5A, there's a lot of variability in the top 50% of the data. In 5B, each chunk of 25% of the data is a little bit different, and there's a lot of variability in this last lower 25%. So in that case, because the data is not symmetric, it's going to be better to use the median and interquartile range. And then we'll look at 6, where it doesn't really give you data, it gives you more of a scenario. So as far as what's better, mean or standard deviation or median and IQR, it's kind of hard to say on this one without having actual data, but we can talk about variability. The political podcast, where people either love it or hate it, is definitely going to have more variability. And the cooking podcast would have less variability because it doesn't seem like anyone really loves it or hates it. So they would be more so kind of in the middle. So if I'm looking at a dot plot, maybe the cooking data is more so in the middle, whereas the political podcast, there's people down here that absolutely hate it, and there's people up here that absolutely love it, think it's the best thing ever. So we can talk about variability in that one, but it's really hard to talk about what's better as far as measure of center or measure variability without having the actual data. Okay, so that's it for lesson 15. You are going to be doing the practice problems today, and we'll be checking all those tomorrow, answering any questions you have. Do your best on them, and again, that lesson summary at the end of this lesson has a lot of examples and information that can help you out. So good luck. If you have any questions, feel free to send me an email, and I will see you tomorrow.